Hi guys, welcome to this tutorial series. So in this tutorial series, I'll be showing you guys how to develop this application that you can see before you. So this application, what it does is that it measures water consumption by suburb. So this is a very basic smart map application, right? So what a smart map is, it's your basic map but with data uh, plotted on it, right? So the data that is plotted on the map is what makes it smart. So you can get insights by just looking at the map and reading the data. For instance, this horizontal bar chart over here and this bubble plot. Okay. Um, so as you can see, the size of the bubbles determine how much water is being consumed in kiloliters per suburb. So each of these bubbles are suburbs in Cape Town. Yes, this is Cape Town. So basically, I developed this application because um, I am very interested in GIS. I like GIS and I love Python. So what I noticed with this is that it's very difficult to get started with Python for GIS, especially when you're using uh, frameworks like GeoDjango and you want to integrate that with Leaflet and you want to add graphs like Chart.js, for instance, to get those different components integrated and working together to develop an application such as this is a bit complicated. So if you follow this tutorial as I am teaching it to you or explaining it to the latter, you will be able to develop application, this precise application as it is before you. So basically, yeah, what I used was PostgresQL and I installed PostGIS extensions. And as a charting library, I used Chart.js. As a GIS front end library, I use Leaflet. And as my web framework, I use Django. So the backend is developed in Python, which is connected to a PostGIS database, and the graphs are developed in Chart.js. Okay, so yeah, I'll be showing you how to develop an application such as this. Um, as you can see here, you have multiple layers. So we don't have, this is called OpenStreetMap, right? So another layer that we'll have is um, Esri's public aerial image. So this is called world, right? So as you can see, it's very high definition. So we'll have multiple layers, right, as our base maps. So you can see if you zoom in and you'll see this bubble over here. So this bubble will tell you what suburb is this, right? Okay, and this will be the aerial base map. And lastly, we'll have a data map, okay? So the data map will make the graphs or the data rather stand out, right? So you can do your basic analysis without having the distraction of seeing other areas of the map or imagery and things like that. So you just focus on the data and these labels that you can see, which are the suburbs. Okay, so yeah, you'll be building up, if you follow this tutorial, we'll be building an application such as this. So this is a GIS application, right? And it's a Python GIS application, okay? So yeah, welcome to this tutorial series, and if you follow it step by step, guys, you will be able to develop an application such as this. Okay, so at a later stage, depending on how much you guys enjoy or find the tutorials useful, I'll also be adding some AI, because I'm a big fan of incorporating the latest technologies into things that I develop. So my tutorial series will have a lot of AI backed applications, okay? Because that is the future, okay? That is the future of application development. So thank you guys. I hope you will enjoy this tutorial. And yeah, so this is Cape Town, and that is Greenpoint Stadium, and these are the suburbs. You might have heard of some of these. So yeah, I hope you enjoy it and you really find it useful. If you do find it useful, please subscribe and give it a thumbs up. And I can guarantee you guys, if you follow this to the latter, you will for sure be able to create an application like this, and then hopefully it will put you in the right spot where you can take it further and incorporate this technology into applications that you might be developing in the GIS space, or any other project that you're busy with. Okay, so it is a very basic smart map, right? um, but it is definitely a good baseline to get you developing applications of your own. So what I noticed was that it's difficult to set this whole all these components and let them work together to develop an application like this. And there's not much help out there. So hopefully this will add some value in the projects that you are busy with, and it will be fun. I think you will enjoy it, and thank you very much. Um, See you guys later. Hi guys, welcome back. In this lesson, we will be downloading and installing Python. So let's open up our web browser. And then we can just search for Python download. Okay, let's click on the first link. So the latest version is 3.9. So you can just click on the download button. Okay, so I have already downloaded it, so I'm just gonna double click on the install file. Okay, so now over here it's important that we check the add Python 3.9 to path, and then just click on install now. Okay, so the setup was successful. So now we need to select this disable path length limit, and then we can close. So now we want to test and see if Python was installed successfully. So let's open up our command line prompt. So now we just type in the word Python. Okay, so as you can see, Python was installed successfully, so we can just exit. So that's it for this video. I'll see you guys in the next one. Hi guys, welcome back. In this lesson, we will be downloading and installing PostgreSQL and PostGIS. So the first thing that we need to do is we need to open up our web browser. Okay, and now let's search for PostgreSQL download. Okay, so we'll be using the postgresql.org URL. So let's click here. Okay, so we'll select the Windows installer. Okay, and then we click on download the installer. Okay, so now let's select the Windows version, and we'll be selecting PostgreSQL Server version 13.3. Okay, so I've already downloaded the file, so I'll just stop this. Okay, so I'll double click the installer to install PostgreSQL. Okay, so let's just click next, and make sure everything is ticked. Okay, so over here, the password that we'll use is just Postgres in small caps. So this makes it easier to remember for this example. So next, we'll keep the default port. Okay, so let's just wait for that to finish installing. And so when the installation completes, we'll have the Stack Builder installation option. So the Stack Builder tool will allow us to download PostGIS. So that will only pop up after PostgreSQL has been installed. Okay, so it's finalizing the installation. Okay, so now PostgreSQL Server is installed. So now you have the option to launch Stack Builder. So we're going to use Stack Builder to install additional add-ons. So the add-ons that we'll be installing is for PostGIS as well as the ODBC driver for PostgreSQL. So make sure that the Stack Builder is checked and then click on Finish. Okay, so over here we can see the Stack Builder window. So we'll just select the PostgreSQL 13 on port 5432 and then next. Okay, so here are a list of the tools that we'll be installing as add-ons. So the first one that we'll install is PG Agent. So this one, we can just check that. And then we also need to install the database driver. So this will allow us to connect to PostgreSQL from any software application. So we'll select the 64-bit version. Okay, and then lastly, we'll select the PostGIS extension. So here we see spatial extensions. So we can just click on there, and then we'll be installing the latest one, which is 3.1. Okay, so make sure that that is all checked, and then click on next, and then next again. Okay, so it will download all of those tools that we have selected, and then it will install them.
Okay, so now we can start installing all the tools. So when you see this window, just click next. Okay, so this is the PG agent setup. Next, next, and the password will be the same as everywhere else, which is Postgres. And then next. System password will also be Postgres. And then next. Okay, don't worry about that. Just click OK. Just click OK. Okay, so now click on Finish. Okay, so now we'll install the ODBC driver. So click on Next. Next, next. Okay, click on Finish, and now we'll install PostGIS. So agree to that, and then make sure you check on Create Spatial Database to see if the functionality works. So it will create a sample spatial database in PostgreSQL, and if that's successful, then we know that PostGIS works. So click on Next, Next, and then the password is still Postgres. Next, install. Click on Yes, Yes, Yes for everything. Okay, and then we'll just wait for it to complete creating the spatial database. Okay, so the installation is successful. Then click on Close, and then Finish. Okay, so now we have successfully installed PostgreSQL and PostGIS. So thanks a lot for tuning in. I'll see you guys in the next lesson. Hi guys, welcome back. In this lesson, we will be creating our spatial database using a tool called pgadmin. So pgadmin will allow us to write data manipulation queries as well as do administrative tasks on PostgreSQL. So let's open up pgadmin. So select Start and then click on the drop down for PostgreSQL. And then click on pgadmin. You can also search for it. So this will start the pgadmin agent and it will run in the background. Okay, so the password we said for everything would be Postgres. Click on OK. Okay, and then click on the servers dropdown. You might be prompted for a password. Again, type in Postgres and then select the save checkbox so you don't need to type it in every time. And then click on databases. So you can see that our PostGIS example database was created for us. So it means that PostGIS is installed and it's working. But we want to create our own spatial database. So right click databases and then select create database. So the name of our database will be CPT water. And then click on save. Okay, so now the next thing that we need to do is we need to create a login role for our database so that we can access the database from our application as well as be able to create tables. So we right click login roles and then select login or group role. Okay, and then the name of our login will be Water Watch in small caps. Okay, and then we select definition and we give it a password. The password will also be Postgres. And then we click on privileges. So we want to make this a super user, so we just select super user. And then we also want to be able to log in with this role. And then we save. Okay, so now we have created our Water Watch login. And now the next thing that we need to do is we need to grant all privileges on our database, which is CPT Water, to this user Water Watch. So we right click CPT Water. And then we select the query tool. Okay, so we're going to execute some simple queries to do this. So grant all privileges on database CPT Water to Water Watch. And then we select the run button. Okay, so we can see query returned successfully. So all the privileges have been given to our database to the Water Watch user, which is what we want. Okay, so now the next thing that we will do is we will add the GIS extensions to our database to make it a spatial database. Okay, so we'll run two queries. So it's create extension PostGIS and then run. Okay, so that was successful. And then the next query that we will run is create extension PostGIS topology, and then click run. Okay, so that was also successful. So now we have created our spatial database. So now our database is capable of storing spatial data. So that will be it for this video. I'll see you guys in the next one. Thank you. Hi guys, welcome back. In this lesson, we will be creating our project folder as well as creating a virtual environment for our application. So the first thing that we need to do is we need to create a folder for our project. So we can right click new folder and we'll call it Ebesis Tutorials. Okay, so let's just place it there and then open up the folder, and inside of our folder we'll create our project folder. So we'll call that Water Watch. Okay, so the next thing that we need to do is open up that folder, and then we are going to copy the path to the folder. So we'll need that path to create our virtual environment. So now let's open up our command line prompt. Okay, so we'll change directory cd and we can paste the location of our Water Watch project folder and then press enter. Okay, so now we are in there, And now the next thing that we're going to do is we're going to use the pip installer to install a tool called virtual env. So virtual env will allow us to create our Python virtual environment. So run pip install virtual env. Okay, so virtual env has been installed successfully. So now the next thing that we need to do is we need to create our virtual environment. So to do that, we will type in virtual env, and then the name of the virtual environment can be any name you want, but we will name it venv because it's more descriptive. Then press enter. Okay, so our virtual environment has been created. So now let's verify that. So we'll just run dir. Okay, so we can see that our venv virtual environment folder was created. We can also verify inside of our project. So we can see here it is. Okay, so now let's test and see if our virtual environment works. So to activate our virtual environment, we will run venv and then backslash scripts and then backslash activate. Okay, so you'll see the prefix is venv. So this means that our virtual environment is active. So any third-party libraries that we will install now will all be installed inside this virtual environment. And that is separate from our system so that we don't have any conflicting third-party libraries. So now just to deactivate it, we can just type in deactivate. Okay, so you can see that venv prefix is gone. So now we're back to our normal system path. So that's it for this video. I'll see you guys in the next one. Hi guys, welcome back. In this lesson, we will be downloading and installing GeoDjango. So GeoDjango is the framework that we'll be using to create spatial applications in Python. So let us open up our web browser. Okay, so we'll search for GeoDjango installation. Okay, so make sure that we click on the GeoDjango installation link in the docs.django project. Okay, and then select Windows. Okay, so scroll down, and then the first thing that we need to do is install this OSGeo for Windows tool. So click on the installer. Okay, and then under Quick Start for OSGeo for Windows users, we'll click on download the OSGeo 4W network installer. So typically this doesn't seem to install when we're using, or it doesn't seem to download when we're using Chrome. So what I do is I either use Edge or Internet Explorer. So we right click the link and then we copy the link address, and then we open up Internet Explorer. You don't have to do all of this if you have Edge. You can just copy and paste the link in Edge and then it will download the file. Okay, so just close this window and then select Tools, Internet Options. and then select security, uncheck the enable protected mode, select custom level, and then scroll down until you find downloads, select enable, and then enable the font, enable the .NET framework, and then select OK, yes, apply, OK, and then OK. Then close Internet Explorer, and then open it up again. Okay, in the search bar, we can paste the link address for our OS Geo for Windows file. Select enter. Okay, so now it will ask us if we want to download the file. Select save. Okay, so the file has been downloaded. Open folder. Okay, so here it is. So I already have a downloaded file. So now you guys should have your setup file as well. So we can double click that. Okay, then we will be selecting Express install. Let me just close all the windows. Okay, so we'll select Express install and then click next. And then just select the first link and then click next. Okay, so now you will be given these options of tools that you want to select. So we will only be installing GDAL, so make sure that that is checked, and then select next. Yes, make sure that is checked, install these packages, and then next. And now it will download and install all our GDAL libraries. So this could take quite some time, so I'll just pause the video until the installation is complete. Okay, so the OS Geo for Windows installation has completed. So now just select finish. Okay, so the next thing that we need to do now is to modify some Windows environment variables so that our GeoDjango application will be able to use the GDAL libraries. So let us hit the back button if you're still in here. If not, then search for GeoDjango installation and then click on the link again. So let's go back. Okay, so we are going to run each and every one of these statements in our command line prompt, and then it will configure our environment variables for OS Geo for Windows as well as our GDAL libraries. Okay, so now let's open up our command line terminal. Okay, so what we'll do is we will just copy these statements line for line. Okay, let's see. Okay, so now let's select the first statement, copy and then paste, then enter, and the next, and so on. Okay, so now we will add these registry modifications. So there's 3 of them actually, so we're not going to take it line for line. We're going to start here and then end at path. So copy that, then enter. Okay, if it says the operation completed successfully, it means that the statement ran successfully. And then we repeat that for the next statement. and then the last one. Okay, so once that is successful, we can now restart our PC for these environment changes to take place. So we can close our command line terminal and then close our web browser. And then we can restart our PC. So actually, we'll end the video here. So just restart the PC so that all the changes can take effect. And that will be it for this video. I'll see you guys in the next one. Thank you. Hi guys, welcome back. So once we have restarted our PC, the changes should have taken place. So now the next thing that we are going to do is we are going to download the Django library using the Python pip installer. So let's open up our project. And then we copy the path again. Okay, and now let's open up our command line prompt. And then change the directory to the path. Okay, and now we activate our virtual environment. Scripts activate. Okay, so once our virtual environment is activated, now we can install our libraries. So pip install Django. Okay, so Django was installed. So the next thing that we need to do is we need to install a library called psychopg2. So pip install psychopg2. So this library will allow us to connect to our Postgresql database from our Django application. And it will also allow us to read and write from our PostgreSQL database. So just install that. Okay, so that's it for this video. I'll see you guys in the next one. Hi guys, welcome back. So in the previous lesson, we installed Django as well as psychopg2. So now the next thing that we need to do is we need to install our IDE. So the IDE that we will be using to write the code of our application is Visual Studio Code. So let's download the IDE and install it. So let's open up our web browser. And then we search for Visual Studio Code, download. Okay, and then select this link for code.visualstudio.com. Okay, and then select the Windows installer. So just want to verify if I have installed mine. Okay, so it's not. So let's just wait until the file is downloaded. Okay, so now let us install Visual Studio. Yes, accept the agreement. So I like to create a desktop icon. Okay, so that's relatively quick. And that will be it for this video. I'll see you guys in the next one. Thank you. Hi guys, welcome back. In this lesson, we will start to create our application. So we are just going to create a Django base application. So we make sure that we are currently in the project folder path. Okay, so to create our Django project, we will run the following statement: Django admin start project, and then the name of the project will be water watch in small caps, and then space and a point, and then press enter. Okay, so now our Django base application should be created. So now let's verify that by running dir. Okay, so now we can see we have our project files created for us. So we can verify that in our project location. So we can see, if we click there, we can see we have our Python files, and we have the manage.py file and the folder for our application. Okay, so now the next thing that we need to do is we need to create another folder which we will call Water Watch app. So Django requires that we have the project folder as well as an app folder. So the app will contain all our model view controller files. So that's basically all the code that we will write for our application. All the server-side code will be inside the Water Watch app folder. Okay, so now let's create that. So make sure that we are in the root directory of our project so that we can use the manage.py file to create the app folder. So we'll run Python manage.py start app, and then the name of our app will be Water Watch app, and then enter. Okay, so now app should be created. Let's verify that. Okay, so now we can see we have our Water Watch app. So now let us verify the files inside. Okay, so we click on our app folder, and you can see we have our models, our views, and our controller, which is our admin.py file. So now we have created a complete Django base project. So now we will start to write the application code for our project. So that will be it for this video. I'll see you guys in the next one. Thank you. Hi guys, welcome back. In this lesson, we will be testing our Django installation. So we will do this by running the application. So the first thing that we need to do is we need to open the project source code inside our IDE. So let's open up Visual Studio Code. Okay, and then select the Explorer button, and then select Open Folder. And then we locate our project source code. So here's our project folder, and then click on Select Folder. Okay, so as you can see, our project has been opened up in our IDE. So the next thing that we need to do is we need to install the Python extension. So we click on extensions, and in the search type in Python. Okay, and then click on this extension that says Python by Microsoft, and then click on install. So we're just waiting for the extension to complete installing. Okay, so the extension has been installed, right? So let's just close this, and we can close this window as well. And let's go back to Explorer. Okay, so now the next thing that we need to do is we need to open up our terminal from within Visual Studio. So we click on View and then Terminal. Okay, so it automatically activated our virtual environment as well, so we can install any third-party libraries from within here as well. Okay, so now the next thing that we are going to do is we are going to run our application server. So to do that, we will use the manage.py file. So let's first make sure that we can list our directory. Okay, so there's the manage.py file in the same directory. So now we run Python manage.py run server. Okay, and then as you can see, our server has started at port 8000 using the localhost IP. So usually I just hover over this IP and then click on follow link, or you can just copy it and paste it in your web browser. So the quickest way is just to click on follow link. Okay, so now we should be able to see this Django page that tells us that the installation worked successfully. So now we know that our Django application is running successfully in this URL. Okay, so that's it for this video. I'll see you guys in the next one. Hi guys, welcome back. In this lesson, we will start to connect our spatial database that we have created to our Django application. So we can close this window, and then we can terminate the server by pressing Ctrl C. Okay, so first we need to install a couple of third-party Python libraries that will allow us to manipulate geospatial data from within our application. So our virtual environment has been activated. So now we can install the libraries. So the first library that we need to install is Django Leaflet. So pip install Django Leaflet. Okay, so that was successfully installed. And the next library that we need to install is Django GeoJSON. So pip install Django GeoJSON. So this will allow us to read and manipulate geospatial data in JSON format. Okay, and then the last library that we will install for now is just GeoJSON. So pip install GeoJSON. Okay, so now we have installed the geo libraries that we need. So now the next thing that we need to do is we need to start modifying our source code. So we will start to modify the settings.py code. So let's click on the settings.py file. Okay, so I'm just gonna increase the size of the font. So to do so, we go to File, Preferences, Settings, and then we search for Zoom. Okay, so you'll see this option that says mouse wheel zoom. So check that. And then once we've done that, we can close this window. So now we should be able to hold in Control and use the mouse wheel to increase and decrease the font. Okay, so the next thing that we are going to do is we are going to add the Django.contrib.gis app inside of installed apps. So we will create another element and we'll call it Django.contrib.gis. Okay, and then we need to add our own app, which is called Water Watch app. So I'll just copy that to avoid any syntax errors. Okay. Just add a comma to make sure it looks the same as the rest of the dictionaries. Okay, so now the next thing that we are going to do is we are going to modify the database connection string, which is over here. So this will define the connection string to allow us to connect to our spatial database. So first of all, the engine that we're using is PostGIS. So we're not using SQLite, so we will replace that. With Django.contrib.gis .db.backends PostGIS. So this is the engine that we will use. And then the name is the name of the database that we will be using. And we said the name of the database would be CPT water. So let's remove that. Okay, so we also need the username that we will need to connect to our database. And the user which we have created in pgadmin was waterwatch. And then we need to add the password to the user, the password for the user. And we said that the password was simply Postgres. So that's the same password that we use for every application. Okay, and then lastly, we need to specify the host. So the host is which IP the database server is running on. And in our case, it's running on localhost. Okay. So now the next thing that we need to do is we need to add the path to the GDAL libraries. So we installed a tool called OSGeo for Windows that will allow us to read geospatial data into our database, as well as allow us to manipulate geospatial data in our application. So the reason why we need to specify the path is because we are using the latest version, and Django currently uses an older version of OSGeo for Windows. So the version that we installed won't be picked up, so we need to specify the path. So the first path is the Geo's library path, and that is in the C drive and the OSGeo for Windows folder, and in the bin folder. This is the file that is expected by Django, and then we're going to add the path to the GDAL library, and that is for the GDAL 303 library. So this version of Django or GeoDjango recognizes version 3.02. So if you don't specify the version for the one that we're using, the application will crash and say that it can't find this library. Okay, so now we've added pretty much all the geospatial libraries that we need for our application. And now we can run the migrate statement so that all the changes that we've applied here will be saved, as well as the connection made to our database will be established. Okay, so let's do that. So first we save the source code. So Control S. And now in our command line, we will run Python manage.py migrate. Okay, so it's making a connection to PostgreSQL, as you can see. And it says that it has applied all migrations and it has connected successfully. As you can see, the OK. So now we have established a connection to our PostgreSQL database from Django. So that's it for this video. I'll see you guys in the next one. Thank you. Hi guys, welcome back. In this lesson, we will be creating the Django admin user. So Django has an administration portal that allows us to connect to our database and then test and see if we can retrieve the data that has been stored in our database. So it's a good tool to use to test to see if you can make a connection to your database. So firstly, we need to create the user so that we can log into the admin console. So to do that, we are going to run the following statement: Python manage.py create super user. Okay, and then the username will be the same as the username for our database. So we want to keep the same username and password. So it's water watch. And then just press enter to skip the email and then enter the password. The password will just be Postgres. And then type it in again. Okay, so we can see the super user has been created successfully. So now let's test and see if we can log into the Django administration portal. So let's run the server. It's Python manage.py, run server. Okay, and now let's open up the URL link for where our server is running. Okay, so now over here, we are going to add a /admin for the admin portal. Okay, so now let's type in our username that we have created. And then the password we said was Postgres. Okay, so let's go to users to verify if our user has been created. So as you can see, we have created our user successfully, which is WaterWatch. Okay, so that's it for this video. I'll see you guys in the next one. Hi guys, welcome back. In this lesson, we will create the model for our application. So the model will be the table where we're storing the data that we will be working with. And that is created in the models.py file. So if you haven't already, you can close the web browser and then terminate the server. Okay, and then the next thing that we need to do is click on models.py. Okay, so now we can add the source code. We'll start by commenting out the first import statement that we see here, because we are not using a standard Django model, we'll be using a GIS model. Okay, so we can add that. So we added this app in our settings.py file, django.contrib.gis, and now we are using its model. If you go back, you can see that we have added it as an app over here. So now we'll use it in our application. Okay, so now the next thing that we need to do is we need to create our model or the table, and that is created over here where you can see create your models. So basically a model is just a class. So I'll copy the class that I have created for the application, and then we'll go through the code. Okay, so it's pretty straightforward. So to create a model, we create it as a class and we give the class a name. We'll call it water consumption, and then we give it a type which is of models.model. So we are saying that this is a geospatial model, and then we add the fields. So we'll have an ID, and then we specify the data type for that field. So this is an integer type field. So you'd say ID is equal to models.integer field, and then we specify that this is a primary key, and then we have a suburb, and that is of type char field, and then we give it a length of 100 characters and so on. Okay, and then we get here. So this will be the field that will store our GPS coordinates. So our latitude and longitude values will be stored in the geom field. So it's of type point field. So this type of field is only available in a GIS model. Okay, so basically this is creating the schema for our table in PostgreSQL. So these will be all our fields in the table, and this will be the data types. This will be the name of the table. So we'll call the table WaterWatch Consumption. Okay, and over here is where we add some metadata. So basically here we're saying that each record in our table will be grouped by a suburb. So the name of the suburb will be unique. So each record will be identified by the suburb. And then if you click on the suburb, you will see all this information for that specific suburb. And this is only necessary in when using the Django admin portal. Otherwise, it doesn't really matter in PostgreSQL. Okay, and then we're just adding the name of, we're giving an alias to our model, how we want our model to appear in the Django admin portal. So we're just giving it the same name as the table name. Okay, and then for instance, if we want to create another table, we just create another class. So we would just be creating another class below, and then we'll give it another name like dams of type model, and then we'll just add the fields ID, etc. So that will be the second table, and the name of the table would be dams, and what you create beneath would be the fields. So that's basically how you create a model in Django, and this model will be converted into a table in PostgreSQL. Okay, so we can save the code. And now the next thing that we need to do is run our migrations to make sure that our changes have been saved and that this table gets created in PostgreSQL. Okay, so we run Python manage.py make migrations. Okay, so you can see that the model will be created. So create model in PostgreSQL. So now we need to run migrate. So Python manage.py migrate, and this will actually save the settings and create the table in PostgreSQL. Okay, so the table has been successfully created for us in PostgreSQL. So in the next upcoming videos, we will be testing this in the Django admin portal. So that's where we will test and see if our data has been stored successfully, and if PostGIS and PostgreSQL have been integrated successfully, and that our application is able to read and write from the Spatial Database. So for now, that's it for this video. I'll see you guys in the next one. Thank you. Hi guys, welcome back. In this lesson, we will be downloading the dataset that we will be working with in our application. So let's open up our web browser. Okay, so we can search for Ebesis GitHub. Okay, and then we select the Water Watch repo, or in case this link doesn't appear, let's just click on Ebesis GitHub. Okay, and then we can select the Water Watch repo. Okay, so the file that we want is this one, which is called waterwatchclean2.xlsx. So we can click on that and then just click on download. Okay, so let's locate the file. So now we copy the file into our project root directory. So we locate our project. So the same place where manage.py is, we paste it there. Okay, so basically our data set contains the water consumption per suburb. for a specific month. So the amount of water consumed in kiloliters by each suburb in Cape Town. Okay, so now that we have done that, we can see that our file is an Excel file. So we have to download the third-party libraries that we need in order to read Excel files, as well as the data manipulation library that we will use to modify the dataset. So we can minimize this and we can close this window. Okay, so we just verify that the file is there. Okay, so now let's install the third-party libraries that we will need to read the Excel file. So the first library that we will install is XLRD. So pip install XLRD, so Excel Reader. And then we run pip install open PyXL. So this is also an Excel reading library. Okay, so that's downloaded successfully. So now the next library that we need to install is the one that we will use to manipulate our data set from our application, which is pandas. So pip install pandas. Okay, so pandas has been successfully installed. So now we have our data manipulation libraries installed. So now let's just let me just give a run through of the data set that we will be working with and how it applies to our application. So our application analyzes the amount of water that gets consumed by each suburb for the given month. Okay, so the value will be in kiloliters, so average monthly kiloliters of water consumed by each suburb. So we want to identify the suburbs that are consuming the most amount of water, and then we want to target those suburbs and then maybe send out an alert email telling them that they are consuming too much water and they need to cut down. Or we can even alert the municipality and they can control the amount of water that gets distributed to those suburbs. So basically that is the reason why we are working with that data set and how it applies to our application. So that's it for this video. I'll see you guys in the next one. Thank you. Hi guys, welcome back. In this lesson, we will add the code for our admin.py file. So let's open up the admin.py file. Okay, so the code that we will add will read from our dataset file that we have downloaded over here. And then we will extract the data into a pandas data frame. And then from there, we will transform the data so that we can store it into our spatial table. But before we do that, we need to use an object from the leaflet class. So we will add the leaflet app in our settings.py file. So let's open that. And then in installed apps, above the WaterWatch app, we will add an app for leaflet. And then add a comma. Okay, and then save the file. And now open up the admin.py file again. So now let's add the code for our admin.py file. So firstly, we will add a couple of import statements. Okay, so we want to add a point object. So this will store our latitude and longitude values into a point field. And then we will also be importing the datetime object in order to get the current date that we will use to insert a record into our table, and so that we can see the date and time in which that record was inserted. And then we will also be using the leaflet GeoAdmin class. So in the admin.py file, you have to register your model as well as a admin class. And instead of importing a standard Django admin class, we will be using the leaflet GeoAdmin class, and we have got that from the leaflet app that we have just added over here. Okay, and then we will import our model. So we need the model to register to the admin class, to the leaflet GeoAdmin. And then we will use pandas to do our data transformation as well as read from the data file. So let's first create a GeoAdmin class. Okay, so basically in order to register this admin class, we need to specify the name of the model over here, as well as append the word admin. So this is what Django requires. And then we specify the type of admin class that we want to use. We want to use the leaflet GeoAdmin class. So that's all you have to do. And now you need to register the class. So it's just admin.site.register. You pass in the model as well as the admin class for that model. So it's just the name of the model and you have to append admin. Okay, so that's what we have to do before we can use the model. Okay, and now the next thing that we need to do is we need to read the contents of our data file into a pandas data frame. Okay, so we just create a variable to store our data frame in. We call it df_excel_reader, and then it's pandas.readExcel in order to read Excel files. If we wanted to read a standard text file, we would use read CSV, and then we specify the location of our file. We dropped it in the root directory of the project, which is the same as we have over here, and then the name of the file. Okay, so now we need to test and see if we are able to read from the file. So we're just going to print the first 5 records of the data frame. So we use the .head function to print the first 5 records of the data frame. So let's save the file and then run it to see if we are able to read from the file. So it's Python manage.py run server. Okay, so as you can see, we have successfully read from our file, and here we can see the contents of the file. We have the suburb field, which is the name of each suburb. We have the average kiloliter consumption value in this field, and then we have the latitude and the longitude value for each suburb. Okay, so now we can terminate the server, Control C. Okay, we can comment out this line because now we know that the data is stored inside of our data frame. And now the next thing that we need to do is we need to loop through each record in the data frame and then write the record to our table. So let's add the code for that. So if you want to loop through a data frame, a pandas data frame, we need to create a for loop. So we specify an index and a row. So all the contents of each row will be stored in this row variable. And then in the name of the data frame dot iter rows. So that's how you loop through a pandas data frame, and then you can read it line by line. Okay, so now the next thing that we need to do is we need to store each value of the record into a variable, and then we are going to use that variable to write the record into our table. So let's extract the records from the data frame into a variable. So we just create a variable with the same name as the field. So for instance, let's start with ID. So ID is just the index, which is the record. So if it's record 0, the ID value will be 0, etc. And then the suburb we extract from the row, and then we search for the suburb field and we extract that value, and so on. And then here we have the longitude and latitude values. So they are in two separate fields. We will combine them into one object, which is of type point. So that's why we've imported the point object. Okay, so now we are ready to save this record into our table. So we are going to use the model that we have imported. So basically, if you want to insert a record, we do the following. We take the field name inside of our model and we assign it the value that we have extracted and stored into this variable. And then to get the suburb, we will say suburb field, and then we add the value which is stored in suburb, and so on. For each field we extract the specific value and then we assign it to a field name from our model. So we'll be doing that for every field. So I'll just copy the code for that. Okay, so once we have done that for every field, we then save that record to our table. So over here we have the geom field, and we use the point object in order to group the longitude and latitude values. So that is how we will be storing the location information for every suburb. And then we specify .save to save the record. So this will loop through every record in our data frame and then store that record into our water consumption table. Okay, so once that is done, we can save this file and then run the server and test and see if our data has been inserted into our table. It's Python manage.py, run server. Okay, so we have no errors. And now we can open up our application in the web browser. So click on follow link. Okay, so now we will verify that the data has been inserted into our table using the Django admin portal. So we add a backslash admin, or forward slash rather. Okay, so firstly we can see that our table was created for us. And now let's click on that. And now we can see the value of every suburb. So our table now contains data that was inserted by our code. And if we open up a suburb, we can see the information that is stored about that suburb. So we have the name, we have the ID value, which was just the index, and then we have the average kiloliters consumed. We have that value, as well as the geom object, which contained the latitude and longitude values. So it stored that as a point. So we can see when we look at the name of the suburb, it matches the suburb name on the map. And you can see that the point is placed accurately inside the suburb. So basically, if you see the leaflet map and the point is accurately plotted, it means that our spatial database has been successfully configured and integrated with our application. So now we can start to move on to creating the visual aspect of our application. So now we can use the data that we have stored in our spatial database and display it on a map. But that is it for this video. I'll see you guys in the next one.